Hello, hi everyone. Welcome to this channel, and today we are going to solve another problem in Leetcode. It's been quite some time that I have not made a video or tried to solve any problem. So let's see what Leetcode has to offer today as a daily challenge. And here we have question named as unique pass. The difficulty level is medium. When you see the related topics, it's related to the maths, dynamic programming and combinatorics. So let's read out the question and we'll try to solve it. There is a robot on an m cross n grid. The robot is initially located at the top left corner, that is at 0, 0. The robot tries to move to the bottom right corner, that is grid m-1, n-1. The robot can only move either down or right at any point in time. Given the two integers m and n, return the number of possible unique paths. Okay, so we have to return the number of possible unique paths that a robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to 2 into raised to the power 10 to 2 into 10 raised to the power 9. Okay, so we have an example here. So for example, robot is standing, we have a grid of 3 rows and 7 columns. So robot is initially starting at 0, 0, 0th row and 0 column, and we have to find the number of possible unique paths that can lead us at this finished position, which is m-1 cross n-1, 2, 6. Okay, and the output is 28. We also have another example, and this is for smaller grid, for which it's easier to understand. So for grid of let's say this is our grid, grid of number of rows is what, 3. So number of row is 3 and number of columns are 2. So that would be 2, 3 and 4. So starting from 1 to reach 4, we have 3 different options: right, down, down. So first we move to 2, then 3, then 4. 1 to 2, 2 to 3, 3 to 4. There's another one, 1 to 2, 2 to 3, 3 to 4. That is down, down, right. And the third one is down, right, down. So 1 to 2, 2 to 3, 3 to 4. So those are the 3 possible unique paths to reach from 1 to 4. Okay, so let's try and understand in breaking down this problem into smaller problems. Since we already know it's a dynamic programming, I mean the related topic to this is dynamic programming, so there must be some smaller solution to it, which we in turn we can use that smaller solution to solve the bigger piece of our problem. Okay, so let's say we have a grid of 3 cross 7, and that should be, let's say it's all 1, 3, 4, 5, 6, 7. Okay, and that's, let's fill this thing as well so that it would be easier for us to calculate. So looking at the first position, if let's suppose if 1 cross 1 was the grid, then the number of possible unique paths would be 1, or some would argue that it would be 0 because we don't have to move anywhere, neither right or neither down. So we can put it at 0 as well, doesn't matter, because we have a, okay, we also have a grid length of 1, number of rows can be 1 and number of columns can be 1. So we can have something as single row and single column grid. Okay, and if the grid size was 1 row and 2 columns, the number of possible paths would have been just to move right. That means only one. I mean, no matter any number of columns, if there is a single row, it would always be 1, because we cannot move anywhere else. Like even if it's the grid size is 1 row and 3 column, we can just move right first and then again right, and there are no other paths to explore that end point. And same with the column. So if we have one single column and multiple rows, it would be again 1. So let's try to look at the options when we have more than 1 columns and more than 1 rows. So let's try to look at this position first. So first row, second row, I mean first index row and second row and second column. So what happens is, I'm sorry for this, what happens is, either we can move to the right and then to the down, which gives us one unique path, and the another unique path would be move down first and then to the right. That means the number of possible unique paths here is 2. Okay, if we choose a grid size of number of rows is 2 and number of columns are 3, then what happens is, to reach initially from here to the final end point here, we have we can move right and then down. That's one unique path. We can move also we don't have to like look into this. Maybe we can consider m equals to 3 and equals to 2 is same. So here the answer would be 3. We already have an example that tells us what the answer would be. So like just starting with this, I can see a pattern that the number that we are looking for is the sum of previous row same column, or same row previous column and previous row same column. Okay, so 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 would be 4, and let's try to solve it this way. 4 plus 1 would be 5, 5 plus 1 would be 6, and 6 plus 1 would be 7. I guess, yeah, that's it. So here 2 plus 1 would be 3, 3 plus 3 would be 6, 6 plus 4 would be 10, 10 plus 5 would be 15, and then what do we have? 15 plus 6 would be 21, and 21 plus 7 would be 28. And yeah, so to reach this position we have 28 unique possible paths. Let's try to code this thing now. Okay, for this what we would like to do is dedicate an array, okay, of obviously length would be, and initialize it with 1. So the number of rows we want is the same, followed by the number of columns. So what we can do is this, yeah, this gives us m number of rows, n number of columns, or am I I have done some mistake. It should be n number of rows, sorry, columns first, followed by m number of rows. That would give us an array of or list of list in Python by default, which has a similar dimension of our inputs. And then what you want to do is, for row in range what m, that's our row. For column in range n, that's our column. So we want to say that our current row and column. So here's another thing, do we have to calculate The first row, I don't think so, that's why we can begin it from 1, and also we don't have to calculate for the first column, so we can begin it from 1 to the n. Okay, and now when we are calculating the matrix values, what we were looking was it should be one of them, row should be -1 and the column should be same. That means if we are calculating for this, column should be the same, and this is the first row. When we are calculating for the second row, we are taking the value from the first row, same column, and we are also taking the value of the same row but previous column. So we are taking the sum of this and this, right? So we have already considered this part. Let's consider this one, and that would be the same row, which means dp of row, and previous column would be dp of column -1. That would give us all these numbers in our dp array, dp list, and we simply want to return the dp of m-1 and n-1. m-1 would be 2 and n-1 would be 6, so dp of 2, 6 would be 28, and that should be our answer. Let's try to see if it works. I mean, there was not a lot of thoughts to be processed for this. I mean, although the difficulty level is medium, we just have to find out how it works. Let's try. Yep, it does. Let's try to submit. Yeah, it's pretty fast, 93.66%. okay, that means we did a great job, and the problem was, I mean, the coding was quite simple once we figured out how to get our answer, right? All right, thank you. If you have any suggestions, please leave it in the comments. अब नेपालीमा हेरौँ है त. सो नेपालीमा चाहिँ भन्दाखेरि यो युनिक पाथ भनेर चाहिँ एउटा प्रब्लम छ, युनिक आजको डेली च्यालेन्जमा, जुन चाहिँ जसको डिफिकल्टी लेभल मिडियम छ र रिलेटेड टपिक्सहरू हेर्दाखेरि चाहिँ डाइनामिक प्रोग्रामिङ, म्याथ र कम्बिनेटोरिक्स टपिकहरूसँग रिलेटेड भएको लेखा छ. र यो प्रब्लम पढ्दाखेरि के छ भनेपछि एउटा रोबोट छ, m इन्टु n ग्रिडमा चाहिँ त्यो मुभ गर्नुपर्ने, तर टप लेफ्टदेखि बटम राइट कर्नरमा मुभ गर्नुपर्ने, र यहाँ रेस्ट्रिक्सन्सहरू के छ भनेपछि रोबोट चाहिँ कि त तल जान सक्छ कि त राइटमा जान सक्छ हैन. अनि हामीले पत्ता लगाउनु पर्ने के छ भनेपछि नम्बर अफ पोसिबल युनिक पाथ पत्ता लगाउनु पर्ने हैन. अब यहाँ दुईटा एक्जाम्पल टेस्ट केसेसहरू छ, एक्जाम्पलहरू छ. त्यो एक्जाम्पल हेऱ्यो भने चाहिँ हामीले के थाहा पाउँछ भने चाहिँ 3x7 छ, 3वटा रो 7वटा कलम छ भनेपछि यहाँबाट सुरु गर्यो अनि त्यसपछि यहाँसम्म पुग्दाखेरि 28वटा लाग्छ. तर यो बुझ्न चाहिँ अलिक गाह्रो छ. यहाँ हामी फेरि हेरौँला कसरी हुन्छ. अनि 3x2 लाई हेर्दाखेरि चाहिँ अलिक सजिलो हुन्छ. त्यो चाहिँ के छ भनेपछि कि त पहिला राइट गएर डाउन जानु पर्यो, त्यस कि त डाउन अनि राइट जानु पर्यो, कि त डाउन राइट डाउन जानु पर्यो. अनि यसरी चाहिँ हाम्रो 3वटा चाहिँ पोसिबल पाथहरू आउँछ. अब यही कुरालाई यो लार्जर एरे अथवा लार्जर ग्रिडमा हेर्दाखेरि के भइरहेछ भनेपछि हामी कुनै पनि रोमा एउटा मात्र रो छ अरे लेट्स सपोज, अनि n नम्बर अफ कलम्स छ भनेपछि वाट इज द नम्बर अफ पोसिबल नम्बर अफ लाइक कतिवटा पोसिबल युनिक पाथ हुन सक्छ भनेर सोध्दाखेरि चाहिँ जहिले पनि 1 हुन्छ. किनभनेपछि हामी कहीँ जानै सक्दैनौँ. राइटतिरै जानुपर्छ, राइटतिरै जानुपर्छ, राइटतिरै जानुपर्छ, राइटतिरै जानुपर्छ. यदि हामी राइटतिरै गइरहेछौँ र यो चाहिँ मेरो एन्डिङ पोइन्ट छ यहाँ स्टार्टिङ पोइन्टबाट भनेपछि एउटा मात्र युनिक पाथ हुने हो हैन. त्यसरी नै हामीसँग टन्न रोहरू छ तर एउटा मात्र कलम छ अरे. अनि त्यति बेला पनि के हुन्छ भनेपछि हामी तल मात्र जान सक्छौँ, लाइक राइट डाउन भनेर चाहिँ छैन, डाउन मात्र हुनसक्छ हाम्रो. सो हामी यो पर्टिकुलर प्लेसहरूको लागि चाहिँ 1 भनेर चाहिँ राख्छौँ हैन. त्यसपछि अब यो टोटल ग्रिड सल्भ गर्नुभन्दा अगाडि चाहिँ हामी एउटा सानो ग्रिडलाई सल्भ गर्न ट्राई गरौँ। के हुन्छ जति बेला चाहिँ हाम्रो नम्बर अफ रो 2 र नम्बर अफ कलम 2 छ भनेपछि अनि हामी के गर्न सक्छौँ, स्टार्टिङ पोइन्ट यो छ र हाम्रो एन्डिङ पोइन्ट चाहिँ यहाँ छ भनेपछि पहिला चाहिँ राइट जान्छौँ अनि त्यसपछि चाहिँ डाउन जान्छौँ अनि हाम्रो पोसिबल अहिलेसम्म नम्बर अफ पोसिबल युनिक पाथ चाहिँ एउटा भयो। अनि अर्को चाहिँ के गर्न सक्छौँ भने चाहिँ पहिला डाउन जान्छौँ त्यसपछि राइट जान्छौँ अनि हाम्रो पोसिबल पाथ के भयो त 2 भयो, किनभने पहिला 1 थियो अहिले चाहिँ 1 एउटा अझै भेटायौँ हामीले 1 + 1 2। त्यसरी नै अब लेट्स सपोज द ग्रिड साइज चाहिँ हाम्रो 2टा रो र 3वटा कलम छ भनेपछि हामीसँग अलरेडी यहाँ आन्सर छ हैन, 3 हुन्छ भनेर हैन। अब यो यति 6वटालाई मात्रै हेर्दाखेरि 1 1 1 1 2 3 लाई मात्रै हेर्दाखेरि मैले के प्याटर्न देखिरहेको छु भनेपछि त्यही रोको प्रिभियस कलम अथवा त्यही कलम तर प्रिभियस रोको जुन नम्बर लाइक पोसिबल पाथ्सहरू छ त्यसलाई चाहिँ हामीले एड गर्दाखेरि हाम्रो आन्सर आउँदो रहेछ। 1 + 1 = 2, 2 + 1 = 3, 3 + 1 = 4, 4 + 1 = 5, + 1 = 6, 6 + 1 = 7 हैन। तर अब चाहिँ यहाँ नम्बर अफ रो मैले एड गरेँ भने चाहिँ अब ठ्याक्कै के हुने भयो, 1 + 2 = 3, 3 + 3 = 6, 6 + 4 = 10, 10 + 5 = 15, 6 21, 7 28 अनि हाम्रो चाहिँ लाइक अन्तिममा चाहिँ जुन भ्याल्यु आउँछ नि त्यही नै हाम्रो आन्सर हुनुपर्छ भनेर। सो यो एकदमै सजिलो छ। पहिला त हामी के गर्छौँ, सबैलाई 1 बाट इनिसियलाइज गर्छौँ अनि सबै 1 बाट इनिसियलाइज गर्यो भने कतिवटा कलम हुनु पर्यो, n वटा कलम हुनु पर्यो र त्यो चाहिँ n वटा कलम भएको कतिवटा रो हुनु पर्यो, m वटा रो हुनु पर्यो। सो मैले चाहिँ एउटा डीपी भनेर मेट्रिक्स लिस्ट अफ लिस्ट चाहिँ इनिसियलाइज गरेँ अनि त्यसपछि चाहिँ म के गर्दैछु, रो 1 देखि m सम्म, किनभने चाहिँ फर्स्ट रो त हामीलाई थाहा नै छ नि त्यो जहिले 1 हुन्छ र हामीले इनिसियलाइज गर्दा पनि 1 गरिसकेका छौँ अनि कलमलाई पनि चाहिँ 1 देखि n सम्म, किनभने चाहिँ यो फर्स्टवाला कलम चाहिँ हाम्रो के छ जहिले 1 हुन्छ र सिन्स इनिसियलाइज लाइक एभ्री एलिमेन्ट इज 1 सबै 1 छ। अब हामी रो र कलमको भ्याल्यु त्यो पर्टिकुलर रो र कलमको भ्याल्यु खोज्दाखेरि के गर्नुपर्छ, पहिलाको रो तर सेम कलम, सो रो -1 कलम प्लस सेम रो तर पुरानो कलम -1 अनि यसरी चाहिँ क्याल्कुलेट गर्दाखेरि हाम्रो यो डीपी लिस्ट अफ लिस्टमा चाहिँ सबै आन्सर बस्या हुन्छ अनि m-1 n-1 गर्यो भने चाहिँ हाम्रो यो अन्तिमको एलिमेन्ट आउँछ अनि यसलाई रन गरेर सबमिट गर्दाखेरि चाहिँ हाम्रो आन्सर एक्सेप्ट भयो अनि एक्सेप्ट हुँदाखेरि चाहिँ इट्स क्वाइट एफिसिएन्ट। सो या त्यति नै हो। अब नेक्स्ट क्वेसन गरौँला अनि हेरौँला यदि कुनै इजी तरिका अथवा केही सुझाव छ भनेपछि कमेन्टमा छोड्दा हुन्छ। Thank you so much. Thank you for watching. Subscribe to the nepCoding. Bye.